Okay, so Dijkstra is going to help our little Lego man to find the shortest way from S to T, the shortest route. So maybe he needs to do this route or whatever. So that's what we're going to find out. How can the Lego man get from here to here as quickly as possible along these roads? Okay? That's what we're going to do. Where's the thingy? Okay, so if we just do this sort of logically, we're going to start at the beginning, right?
Yes.
If he goes to A, that would be a distance of 5. Okay? So the shortest distance, well, so far that we know of to get to A is 5. Okay. The shortest distance that we know of so far to get to B is 6. Okay. And we remember the number 6 and we remember the number 5 as being the shortest distance that we know of so far to get to those various vertices A and B. Okay. The shortest distance that we know of so far to get to C is 2. Okay. Now, so far we're remembering a 5, a 6 and a 2. And obviously we're trying to do the shortest route, so we go with the 2. Okay, so this is definitely going to be the shortest distance to C.
Absolutely.
Now, once we're at C, we could go off to B. That would be an extra 2. So that would mean that we could get to B a distance of 4. Now, a minute ago we were remembering 6 because we knew we could get to B at a distance of 6. We've now discovered that actually we can get there a distance of 4. So we're going to stop remembering 6 and start remembering 4. We could also go from C all the way to T. So actually we now know that we could get to T with a distance of 14. So we'll remember 14. That might be the shortest one possible. So far, the smallest thing that we're remembering is a 4.
Okay.
Here. So let's stick to this. This is now 4. Now from here, we could head off along to T, and that would be another distance of 8, so that would be a total of 12 altogether. Okay, what were we remembering for the point T?
14.
14.
Which
now,
is larger.
Exactly, which is larger than 12. So we'll forget 14 and remember 12. Okay, so this is now 12, which is the shortest so far. And the shortest up to D that we know of is going to be 8. So we're remembering 8, we're remembering 5, and we're remembering 12. Now of those, the smallest is 5. So if we go and look at A, maybe going via A is going to actually be shorter overall.
Maybe.
So we're remembering 5 here. Okay. If we travel along here, we get to D a distance of 9. Now is that bigger or smaller than what we were already remembering for D?
Well, it's smaller than 10, so yeah.
Where did we get 10 from?
Going from S to B
yep,
to D.
But we'd stopped remembering 6 yes. Because
it's larger than 8.
4.
Yeah.
So it's exactly. It's larger than 8. So actually we still remember 8 for the point D because we know we can get there in 8. Okay? So we're remembering 8 for D and we're remembering 12 for T.
Okay.
Now, D is the next smallest. So if we think about starting at D, we've already travelled 12. If we go another 3 along here, that will be 15 in total. But that doesn't beat what we already knew, which was 12.
Okay.
So in doing what we just did, we've done every possibility of ways of moving around.
Okay. And
the smallest possible way that we could possibly get to T is by 12.
No, it's 11 because there's 11. 2, 2, 4, 3.
2, 2, 4. Oh, did I forget what I was remembering?
Yeah.
Okay, well, I did that deliberately to demonstrate that we need to write down what we're remembering. I didn't actually, but we do. So what we do is we have these little boxes on each vertex, and they look like this. Okay. And on each box, they have the vertex name, A, B, C, D, E, S, T, whatever, and the working values are the remember numbers. So we don't have to remember them. We only write them down if they're smaller than something we already found, because otherwise, why do we bother? So if we know, for example, that we can get to B by 4, we get rid of the 6.
Okay.
But if we find out that we can get to something in a longer way than something we already knew, we don't bother writing it down because it's longer than something we already knew. Then when we work out that the quickest way we can possibly get to that point, so for example, B, the quickest we could get there is 4. There's no way we could get there quicker than 4. Then we write that as the final value in the top right. Okay?
Cool. Okay.
So this network turns into this. And we're going to start off in exactly the way that we did before. So like the same idea, but the remember numbers will get written down, that's all.
Okay.
So we're going to start at S. Yeah. So the order of labelling is a 1, so we put a 1 next to the S, that's where we go first. And so far we have travelled nowhere. Good. Now, we thought, how long would it be to go from S to C? And we put a 2 down here. We remember the 2.
Okay.
And S to B, we remembered a 6. We're not going to put it there yet.
Arms.
We're going to put it, sorry, yeah, go. We're going to put it there as a remember number, because it might not be, actually it turns out not to be the smallest, doesn't it?
Yeah.
Because we actually end up getting there by 4. Okay, what about to get to A, the shortest, that's it, that's 5. Now a little tip, because this is quite a simple network, but when they get more complicated, there's lines all over the place. As you do what's called updating, which is think these numbers,
Okay.
just do a little scribble along the arc that you considered. And each line in this network should get scribbled once.
Okay.
So it helps avoid errors. So if you scribble along S to C, because we considered that one, and scribble along S to B, perfect. And as we consider them, we will scribble along just to make sure we're not missing anything.
Okay.
Okay, so what we then did was we said, well, out of these, the smallest is C.
Okay.
So we'll go there next. So we put a 2 next to the C, because we've gone there second, and we put a 2 as the final value. The shortest way to get here is 2.
Okay.
Now, we're going to update from here. So scribble along from C to B, and add the 2, which is the C to B distance, to the 2, which was our final value for C,
So that's
to get
4.
4. Now that's smaller than 6. We
So
don't,
shall I
well,
cross 6 out?
we're showing method because it's an exam, so we go comma 4. Yeah, just so that they can see that you did write a 6. Because if you crossed it out, it would be gone.
Okay.
That's it. So we've done that one. We also need to update from C to T, because we update from everything we've just been to. So we update along there. So this working value is going to be 2 at 12, 14. So that means we could get to T, the distance of 14,
Okay.
but it may not be the smallest. Okay, what's the smallest working value that we've got?
It's 4.
Brilliant, it's 4. So we go there next. So we're going there third. And our final value for B is a 4. Perfect. Now you're going to update everything coming out of B.
Okay.
So along from B to D. Perfect. Now what will that working value be?
It'll be 8.
Perfect, 8. That means we could get to D by 8, but
Okay.
it may not be the smallest. Also, we need to update from B to T. And that working value will be 12, which is smaller. So we write it down. Exactly. Perfect. Now, what's the smallest working value we've got now?
Like 8. Yes.
8 isn't the smallest. Have another look. What working values have we got? Look over the whole network.
Oh, 5.
5, yes. And it tends to get lost, that 5 up in the air. Anything
Okay.
that's slightly to the left, when you're doing Dijkstra, can get lost. So it's always worth looking right the way over your network. What's the smallest?
Okay.
So we're going to A next. What number are we on? How many have we done? What order of labelling are we on?
Oh, we're on the 4.
We're on the... Yes, we're on the 4th, you're right. We've got S first, then C second, then B third, and now we're on the 4th. So A has order of labelling 4, because it comes after B, which was third.
Okay.
And the final working value for A is 5.
Okay.
That's the absolute quickest we can get to A, is 5. So 5 goes in the final thing. That's it. Then we update from A, and we get a new working value. Now this working value, 5 add 4, is 9. So we could get to D by going via A, but that would be a distance of 9. We already know that we can get there a distance of 8.
Okay, so we just don't write that in.
Yeah, we just don't write it in, exactly.
Okay.
Okay, now 8 is our smallest. Okay, so we can choose D fifth with a final value of 8. Perfect. And then we're going to update from D.
Okay, so the only way we can go is down here,
Mm-hmm.
which gives us a value of 11,
Perfect.
which is smaller than both 12 and 4.
Uh-huh. T.
Yes, T.
14.
14, yes.
Okay, so now our smallest working value is 11, which is on the T. So we choose this 6th.
Yes.
And the final working value, which is the shortest possible distance from S to T, is 11. Okay. Now, a really, really, really basic check is this number here, order of labelling. We should have labelled, according to us, 1, 2, 3, 4, 5, 6, which means there should be 6 vertices, 6 boxes.
Oh, okay.
1, 2, 3, 4, 5, 6.
Okay.
Correct. correct. Obviously, you wouldn't put massive ticks over your work in an exam, but it's just a really quick check that you haven't accidentally gone wrong with the order of labelling. And the other thing that we did to avoid mistakes is this scribbling. Okay?
Okay.
Good. Make sense?
Yes.
Excellent. Okay, we're going to try one more. Yeah. This is more like what you get in an exam, this sort of size.
Okay.
Okay? So we'll start with S.
Okay.
So we go to S first, and we've travelled a distance of
Of 0.
And then we update from S.
So, first I go to B.
Yep, you can do it in any order you like. But yeah.
And the distance to B is 6.
Yep. That may or may not be the shortest way to B, so we
So
put it
I'll
as a
just put
working
that.
value.
And the distance to A is 7.
Yep.
And the distance to D is 16.
Perfect.
And the shortest distance is the one to B, which is 6.
Perfect.
So we expand out.
Go there second.
Go there
Yep.
second. Then expand out from B.
Yes, and we're going to make a note that the final working value for B was 6. That's it? Perfect.
Absolutely.
And then we're going to expand out from B, yeah.
Okay. And there's 3 down here,
Yeah.
which is 9.
Perfect.
And there's 8 up
Mhm.
here, which is 14.
Yep. Okay, that's all our updating done.
Okay. And as this is smaller, we... Oh, yeah. Okay.
7 is the smallest.
Oh, okay, yeah.
Because our working values at the moment are E9, D14 and A7.
Okay.
So the smallest is A7.
So I put a 3
Yep,
here.
so we're going to go there third, and the final value we got for A is 7.
Okay.
Yep.
And I can either go to D,
Yep.
which takes 12,
Yep. Mhm.
or I can go to C,
Yep.
which takes 17.
Yep.
Now the smallest working value I have is E9.
Yep, that's right.
So I will put 9 in as the final
Yep,
value.
good.
And 4 in.
Yep. Excellent.
And then I will update.
Yep.
I can get to H with 13.
Mhm.
I can get to G with 15.
Yep.
Okay. And now the smallest working value I have is 12.
Perfect.
So now I go to, I put a 5 in because it's the fifth one I'm checking, and I put 12 as the smallest value.
Yep.
Now I update. I
Yep.
can go to C
Yep.
with 16.
Yep.
I can go to D,
Yep.
G with 18.
Yep. Now we wouldn't actually bother writing that 18 down
No, we
because
wouldn't.
we already know we can get to G with 15 by another route.
Thank you.
So we probably just wouldn't bother it. Yeah, that's it.
Yep. Okay. And the smallest working value I have now is 13.
Yep.
So I'll visit that 6. I will go up to G, which will take 14
Yep.
overall. And I can also go up to T,
Yep.
which will take 23.
Yeah. And when we chose it as the 6th one, we put the 13 in as the final value. That's it. Good.
And now the smallest value I have is 14.
Yep.
So I can either get up to C with 15.
Yep.
Or I can go over to T with 22.
Yep.
Now, the smallest value I
Wait
have...
one sec, because when you've got to G, that's it. Yeah, you need to say
7.
G was 7th with the final value of 14. Yes, that's it.
Okay.
Yeah.
And now the smallest one I have is 15.
Yep.
C.
Yep.
So I'll put it in 8
Yep.
with a final value of 15.
Yep.
I can get to F with 18.
Yep.
And now the smallest value I have is F is 18.
Yep, correct.
So I'll put that in 9.
Yep.
Final value of 18.
Yep, perfect.
And I can come down here for 20.
Yep.
The shortest value is 20.
Perfect. And then if we do our little check, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and you've got a final order of 10. So you haven't gone wrong on that either. Okay, if you're watching the video, you're now going to try these two on your own. So pause the video, and then I'm going to wait 5 seconds, and I'll put the answers up so you can check your answers. But do pause the video and try this yourself. Okay, so this is the answers to the first one. I've highlighted the actual route, but I'm going to do that on the next video, how you find the actual route through the network. For now, you're just looking at the blue writing, which is all the numbers in all the boxes. And this is the second one. This is the answers. Again, at the moment, you're just looking at the blue boxes, not the yellow lines. So hopefully you got those right. So again, what can go wrong? It's really easy. You've got strategies for things not to go wrong. One of the basic things is units. So if you don't put kilometres as the final length isn't 28, it's 28 kilometres is the minimum length. You've also got, this actually happens, I don't even know why, but a lot. What is the shortest distance from A to G? Apparently the shortest distance is ABDFG, which is not in fact a distance. This happens quite a lot. Here we've got an example of the basic checks. So this was number 8, order 8, and then this was also ordered 8. So the final number here wouldn't have equaled the number of vertices at all. And last one, this one wasn't updated. So one of the lines got missed, one of the arcs, and that's why the scribbling over the line thing is a good idea, because it makes sure that you don't miss anything. Okay, so we're going to make some notes, and so if you pause the video and write down the notes that I'm going to show in 1 second. So these are the notes that you need to write into your pack. This algorithm is for finding the shortest distance and path through a network. In the next video, we're going to see how to find the actual path. You start by labelling the start vertex with an order 1 and final value, as in distance travelled, 0. You then update the working values from that vertex that you just chose, and then have a look at all of the working values and choose the vertex with the smallest working value, update the order and final working value of that vertex, and then repeat the process. Update, look for the smallest, update, look for the smallest, and continue until you get to the end. Pause the video if you need to write down these notes. Okay, so some checks that you might want to write down. Units, really important, checking that you've read the question properly. As I said, scribbling along the arcs as you update them. And personally, I use a calculator to do adding because I can't add in my head without going wrong. Okay, I hope you understood the video, and if you go on to the next video, you'll see how to find the actual path through the network, not just the distance.